green light. Green light. 12 minutes. Oh my God, no, just a second. Okay, it's like apocalypse countdown. All right, everybody. You know, this is the 60? No, not 16, it's 60 meeting already.
We are sold.
You know, so like it happened like 4 times in the year or 6 times in the year, AWS user meeting Kraków. So if it's going to be 60, could you make math quickly? You know, 60 divided by, okay, let's do it like 6. Okay, it's 10 years. It's impossible. It's impossible. So we messed up the numeration as usual. Welcome everybody on AWS User Group meeting in Kraków. We are here in Hevre on site and in cloud somewhere on YouTube. So you can join from both channels. This event today happening. Thank you to the partner PMI, who guys will join us in a second. They will have a lovely presentation about how to save millions on AWS, which is catchphrase. I hope you're not spending millions, or maybe you
We are spending a lot
of millions. Okay, cool. So we will start shortly with the first presentation, but we'll do the pick. We'll pick the users on the end of our meeting that they will reply on the questions. The questions will appear both here on the big screen, right, and on the small screens that you have in home because you didn't came here, right? So, well, Kuba and Piotr.
Yes,
I think
so
we can start. Perfect. Look, the stage is yours, guys. Enjoy it.
Thank you. So, welcome, guys. Today, as we mentioned, we'll speak about savings and money, how to save millions on AWS. Together with me, we have Kuba, but let's share our agenda. So first, it will be like a really short introduction about us and the company, what we are doing and why we are here. And then we will try to go straight forward to the cost optimization, why we need it, how we are doing it in PMI, and how much we managed to save so far, like on the yearly basis. And then in the second part of the presentation, Jakub will show us the tool which is shared with the whole community by AWS. The tool is named Instance Scheduler. It's not one of the services, but the tool fully supported by the vendor. However, in PMI, we adopted this tool in a slightly different way because it's based on CloudFormation, and we managed to rebuild it using Terraform as our main infrastructure as a code tool is Terraform. And Jakub will share how we did that, and he will also provide short demo how to use it. So let's start with Jakub.
Yeah, hello guys, I'm Kuba, and I've been working in IT since 2015. However, as a cloud ops engineer, I'm working since 2020. And basically, in my work, I focus mainly in AWS and other cloud providers. However, in PMI, I work as a cloud ops engineer.
Thank you, Kuba. More about me, I'm quite often here on the stage, so I will not speak long, but recently I switched my position from cloud manager to DevOps manager. So I'm more focusing right now on the tools and best DevOps practices, but still working closely with public cloud and especially with AWS. About my experience in these areas, like total over 20 years with infrastructure, but 5 strictly related to public cloud services. And about our company, so Philip Morris is a huge international tobacco company, one of many, I would say. But why we are here? We are here because we are trying to be technology-driven company. So we are not only tobacco producer, but we are trying to deliver new products, reduced grease products. Maybe some of you heard about this. And for these products, we are using Hevre technology. And we are doing also automate a lot of factory processes. And through this, we managed to build 3 hubs. One of these hubs, IT Hub Kraków, is located here in Poland. And we have more than 300 specialists. I was checking on the webpage like just before the meeting, and it's even more than 400 right now. We have in the total as a company 71,000 employees, but only in Kraków we have more than 20 different nationalities working on for the IT hub, and 33% of these are women. About the departments, so it's not only, okay, it's mostly cloud related, the new technologies, yes, but we have everything which is close to this modern solution, like artificial intelligence, big data, a lot of solution which may sounds like on-premise related to networking, but we are using also modern technologies in the cloud, and we are creating network based on the software, yeah? So infrastructure as a code as well. And of course, we have UX departments. We have those who are managing projects using both waterfall and agile technology, Scrum. So if you are looking for IT positions, right now we have more than 40 openings. More than welcome if you would like to join us. So let's start. Why we need cost optimization? It sounds obvious, yeah, to maximize business benefits, save money. Yeah, for beer. It would be nice to save this money and transfer to our private accounts, yes, but it's not happening that way. But the main goal, from my perspective, is not to just burn out these resources, this money. It's better to utilize it in the more effective way, or maybe move these resources to start some POC tests and try different technologies. So what else? Improve performance. How improve performance is connected with like cost optimization? Just by checking what you are using, you can optimize your infrastructure in public cloud, use the latest version of the machines, of the storage and so on, and then you will really save money, and you'll increase your performance. I will show you later how big impact is related to these small changes. Reduce cloud waste. So this I already mentioned. We would like to save and not just burn something what is over provision, to use the budget for important projects, business, or security requirements. Yeah? As you know, security is also really important in public cloud, and you need to make some investment on it to make it safe. So benefits, quite obvious: reduce cloud costs, have the right sizing, apply discounts. Also, if you are like managing huge environment, I'm not saying about two single instances, you can utilize the discounts, not only from AWS, but from different providers. And of course, eliminate waste. But they are like challenges related to the way how to achieve that. So governance is really important. You should define policy, apply this policy, and follow these rules. So, for example, to not allow people over provisioning, so check their architecture, but also not allowed to use the old type of instances or old type of storage. This is one of the examples. And of course, have a proper architecture review. So keep the architecture discipline. If you can utilize something which is more modern and cost effective, use auto-scaling, push for that, not ask people just to move from on-premise what they have there and deploy it in the cloud, because it will be simple, the waste. And then the whole rest related to work of IT operations. So whole change management, dashboard, when we are sharing with our teams, with our customers, products product team, how they are spending money to make the awareness. Yeah? Because most of the, all types of service managers or product owners will say, I had the budget, I'm paying for the resources, I'm still in line with the budget, so why I should worry about the spendings? If everything is working fine, why I should even take care for any optimization? And this is the main mistake, the common mistake, because we used to purchase the servers as a part of a CapEx. It was long time investment, and we were like utilizing what is there. It doesn't matter. It's working on the 50, 70, or 25% of resource utilization. It was working. It was paid. No one cares. Here we really care because we are paying what we are like using. And if we are like decide to use something which is not utilized, we are paying simply more and waste the money. So cooperation with product owners, service managers is also really important. And we are doing it also to share similar sessions, similar awareness session with all our product owners, service managers, and we even had 2 today. So this is what we are doing. And how do you think? What are the like top 3 costs by product families, not only in AWS, but generally? Any idea? Salaries. Salaries, yes, but I am talking about resources. So infrastructure, services. Transfer is one of them, yes, if you are like having a lot of public services, but if you are like deploying resources for your own usage, and you really don't have a lot of transfer, you have direct connect, then EC2, exactly. So compute is one of the most, I would say, costly product in our case. Then we have database services, and of the last one is storage. So I will try to quickly focus on this 3 and share quick tips, tricks, how we are saving money on this. So first, stop running resources while they are not in use. How to do this in the fully automated way, Jakub will share. But if you have only like few instances in your product, you can easily stop unused resources like dev QA environment. When there is no development, you are just running production and you need to check something only before new release, yes? So there is like really waste running all these environments 24/7. So can we do it for every resources? There are some limitations. So easily you can stop EC2 instances, but if you are speaking, for example, about the database using RDS service, you can stop it, but then after 7 days it will launch automatically to keep the service up to date. So AWS is applying some rules to patch the RDS, keep the latest version. You need to be careful with the service. So, okay, I stopped our QA or dev database, saving money. No, after 7 days, it will start again. So you need to set up some automatization to avoid the situation that it will resume. And there are other cases which also Jakub will cover. You need a maintenance window to deploy patches also for dev and QA. Then if the instance is stopped, it will not apply the patches. So you need to somehow bring it back for a few hours and patch the systems. Proper sizing of the resources. In many cases, I saw situation that we are simply doing the lift and shift from on-premise, whatever we had there, and then we can end up with like really huge servers just burning money, especially like I saw many cases, Windows servers with SQL database on it, and really over provision because this is like requirements from the vendor to have, I don't know, 16 CPUs, 48 or 128 gigs of RAM, and we are using 20%, yes? So Choose the right EC2 instances family. So general purpose, compute optimized, memory optimized. Maybe you don't need really 16 CPU. You will be fine with 4. You just need more memory. Try to analyze, try to test it properly. So monitor and change instance type on size whenever it's required. This is like one of the benefits of public cloud. You can change the instance type almost in the fly and simply adjust to your requirements. And it should continue that way. So we should provision, then we should monitor, then we should resize, review the performances if we are okay, and if the resources are not needed, just retire it. How to do this? You can use the cost optimization report, which is available in AWS console. You can use advanced tools. There is many ways, but the simple one are like built in what you have in AWS already. The other solution is, of course, auto-scaling, or consider to use containerized solution. But also, just be careful. Do not deploy the whole EKS stack just for a single pod. Yeah, it will be simply the waste. And I saw such solutions as well. Use the latest technology. I will repeat myself, but this is really, really important. So they are like new types of instances using, for example, new generation tabs, and they cost less. Why they cost less? Because they use new CPUs, and AWS doesn't have to maintain the old ones. Yeah, so buying the old stuff, buying the old type of storage, it becomes more costly in the time. If the clients are still provisioning all types of storage or type of instances because they simply use two, they don't want to change, it will increase the price, yes? So try to use the latest resources, and it will also benefit in the other way. You will receive better performance. And just to show 3 simple examples, changing from GP2 to GP3 type of storage, save in PMI 20% on EBS volumes. And we have one of my colleagues from my team member, former team member, Ivana, she did this exercise for many accounts, and it really benefits. It is not a like really simple task. You need to take a snapshot and restore it with a new GP3 types, but you can apply this, have a proper change management, and save the money. Next thing, maybe not so, I would say, huge, 9.5%, but still, if you are speaking about millions, you can save a lot, yeah? Switch from T2 to T3 instances, for example. And the last one related to conversion of the database types and instance types related to these databases, you can save, in this case, for RDSs, Aurora, MySQL, Postgres, MariaDB, up to 11%. This is based on our experience and what we managed to achieve during the last year. Another example, which I already mentioned, so is to use auto-scaling. When you are like deploying standard instances, and they are like over-provisioned, but why they are over-provisioned? Because we have peaks. Yeah, we have peaks. We need to be prepared for this huge demand, but it's like once per day or twice per day. Why, in this case, we should not use auto-scaling? Yes, we can simply switch to auto-scaling, properly design our services, and optimize costs, improve the highability, because we'll have more than 1 or 2 instances, so our resilience will increase. And in the same time, we can save up to 40%. This is like simple case. Maybe the amount is not huge in the dollars, but in the percentage it is 40%. And if you multiply by 100 accounts, which similar resources, you can save really a lot. The last thing which we are doing is to use reserve instances or spot instances. The spot instances utilization is not as big I would like to have in PMI. but still we are trying to use it. But on the cost management level, what we are doing, we are focusing our reserve instances, or the next thing, which I will share in a moment, on some other savings which we can apply. But I would like to share with you the spot instances topic, which as I mentioned, they are not really utilized in PMI, and I would like to change it in the future. The spot instances you can easily use on the order and deploy and mix with reserve instances or standard on-demand resources and save up to 90% discount. However, there is a trick, yeah? This instance can be terminated with a really quick buy if someone will request it, similar instance with standard price in 2 minutes notice. So it's pretty fast. And if you would like to have only spot instances, it will simply not work. So you need to mix it with standard types or reserve instances, and also mix the different types of EC2. So if you have properly designed architecture for CI/CD deployments, when you can cover situation that one of your instance or 10 of your instance will simply go down in 2 minutes, and you will just restart normal on-demand instances in place, you will save the money when it's possible, and you will be covered in case of such situation. Also, if you have high requirements for computing, but it's not really important to run it all the time. So you need to do a calculation. We will take, I don't know, 20, 50 hours. You can use spot instances, do the calculation, and then you simply don't care if one of two of them will fail. Yeah, I mean, stop working, and you will save a lot. And the last thing which I would like to share with you is the saving plan. So if you have a really huge demand, huge utilization of AWS resources, you are paying millions, just try to estimate your infrastructure usage commitment and speak with your vendor, whatever it's Google Cloud, AWS, or Azure, and then you can apply the savings plans. There are different options of commitments, so you can declare you will use it for 1 year or 3 years, and covering this you can save a lot. What is giving you more comparing to reserve instances, that you can apply the savings not only to particular instance, but to the whole environment you have. So if you are launching new resources, new AWS account, it can benefit from these saving plans immediately, and you don't really care if it's one instance type or another, or if someone will reduce the infrastructure, will simply move in the fully automated way to different accounts, the saving plan, and utilize it there. And how much we can save, I will show you in a minute, but in total, just applying these simple steps, we managed to save last year 4 million. 4 million, which we can reuse on different solutions, different resources. And there is many more things, and there is whole, I would say, page dedicated to the way how you should take care of your cost and how you should use AWS tools to optimize it. One of these, which I mentioned, is Cost Explorer. When you can see your costs related to particular services, you can set the limits, the budget for your account, and you can simply notice if you are starting to overspend. And here I would like to share my private example. I have a blog running in the AWS private travel blog, which I am spending almost nothing. It's $6 per month. It's one EC2 instance, automated snapshot, and so on. And I have second instance using for development when I need to apply patches and I would like to test new WordPress features if it will work fine or not. Or I'm doing upgrades from time to time. And I set the limits. So I would not like to spend more than $7 per month. And I did some tests, I applied the patches, and I received after 1 week notification that we are predicting that this month you will spend not $7, but $12. Okay, still not too much, but okay, what happened? Yeah, I forgot to switch off this dev instance. And the second thing, I did 2 snapshots before I applied to the production the new version of the WordPress, and I forgot to delete the old ones. Yes, in my case, it's not fully automated; it's manual, but still, this monitoring allows me to save these few dollars. The rest I already shared. Yeah, so identify EBS volumes with low utilization. Just another example. We noticed that we have EBS volumes detached from the instance because the instance were already removed, and no one did the EBS volumes or the old snapshots. We managed to save on single AWS account $17,000 per year, just doing proper cleanup. And of course, if you are using infrastructure as a code based on Terraform, you can automate it, but sometimes people just are online, going to the console, doing the snapshot, they would like to test something, and they simply forget that they did it. Analyze Amazon S3 usage. This is another step. RDS, Redshift, instances with low utilization, DynamoDB, networking, reduce costs by deleting idle load balancers. Load balancers is another example, yeah? So you'll say $19 per load balancer is not a lot. But if you have like cluster with EKS and then you are creating not 1, but 10 or 20, or I had the case with 100 load balancer on one account, just with proper configuration, you can reduce this cost and have like 4 of them to manage the same resources. So paying 100 times 19 or 4 times 19 is like huge difference. Spot instances, already mentioned, auto scaling, already mentioned. So these are like recommendation coming from AWS. You can see the link on the bottom directly from AWS webpage, and you can investigate more there. Now, I will give you the really quick introduction to AWS Instance Scheduler. I will ask my colleague Jakub to join me on the stage. But what is about Instance Scheduler is the way how you can automate the process which I mentioned, to start, stop instances. And as I said, we apply all these, I would say, best practices to have reserve instances, saving plans, and so on. And we still notice that we are paying a lot for on-demand. And this on-demand is mainly related to dev and QA. Yeah? So people are still running the instances in dev and QA 24/7, and we are simply paying for this because we apply saving plans only for production, yeah? Which we predict that we will reuse in the 1 or 3 years. And this is not our final saving. This is the estimation which we would like to achieve in the future when we apply this to all accounts. But just based on the simple calculation, we noticed that we can only stopping the instance in the automated way for weekends. So have it switch for 48 hours, we can save up to 29%, which in our case is giving $1.3 million. So is a lot. If we manage to convince our product owner, service manager, to not utilize these resources like dev and QA environment after working hours, so when developers are not really working on, there is no test, and plus weekends, we can save up to 76%, which is giving a really huge amount, $3.5 million. These are rough estimation. I would say that we will be more closer to this 1 million than 3.5, but just would like to show you how big saving you can achieve if you properly manage your infrastructure. Thank you, and the stage is yours, Jakub.
Okay, thank you, Piotr, for your presentation. Today, I would like to talk about the instance scheduler as the automation way of saving the costs. Basically, we can save the money on the dev and QA instances. I don't want to talk about the production instances because I don't think if your customers will be happy to turn off production instance, for example, during the night. However, sometimes there are some cases that instance scheduler can be applicable. My presentation will be in the two parts. Firstly, I'm going to look at the topic of our session, what the instance scheduler is, and the second part will be the quick demo. However, I have less time than I expected, so we'll see. And I would like to talk about the benefits of using the instance scheduler and talk about the features. I would like to show you how to implement instance scheduler on your account, and we will see also Terraform module, which I prepared. Yeah, as I said, live demo, and I would be happy to answer any questions after my session if you will have. Okay, instance scheduler, what is it? This is not the service from the AWS. This is the solution which have been prepared by AWS company. Natively, they prepare the instance scheduler in a CloudFormation template. However, our customers using Terraform, then we decided to rewrite the entire solution to Terraform. Of course, only the infrastructure part is rewritten to the Terraform because other parts like Lambda is basically stays the same. Instance scheduler can helps you control your AWS cost by configuring start and stop instances and RDS instances as well. It's really easy to deploy, to manage. And what is worth to mention that it's a fully cross-account solution, so it can be deployed in one account, and others accounts can use this solution as well. Of course, you need to have a special AMI permissions, but I will talk about that later. Instance scheduler has also very friendly CLI, which provides you the possibility to create the schedules and periods using a very simple CLI. As I mentioned, AWS Instance Scheduler is fully supported by AWS. People who work in AWS still contributing this solution. A lot of plans in the future about this instance scheduler, but then I will talk about it later. From the analysis, customers who use instance scheduler can save even up to 70% compared to the, of course, running instances 24/7. Something like that. And now let's discuss about the architecture, because it's I think the most important thing, how it's built. First of all, our Terraform will create something like CloudWatch event at a customer-defined interval. And this event invokes Lambda function which basically will looking for the special tags in EC2 instance, and then based on this interval, something like the cron job is running, then it will disable or it will start the specific instance. So the lambda is something like the heart of the solution. It's really big lambda function which is deployed. And also DynamoDB is used, and inside the DynamoDB there is all the values related to the configuration of the scheduler. All the periods or the schedules are stored there, and the lambda function retrieves those values each time when it runs. Yeah, and as I said, if you have some resources to schedule, you need to define the specific tag, and the resource is the EC2 or RDS, and based on that, the lambda is looking for the specific resource, and then it makes some action. All the information related to the scheduler is saved in CloudWatch, so you can check all the debugging logs, all the trouble. If you have any problems with the scheduler, you can check on the logs, and all the information are stored there. There are some free log groups which are divided by the configuration, and it's really useful stuff. Other components which are deployed are KMS, SNS, and AMM. So the solution creates the AWS managed customer key, which is used by SNS and by DynamoDB. And thanks to that, those information are secure. And also, if you have, for example, idea to integrate with some Slack or Teams, you can use SNS topic, and based on the specific action which instance scheduler will execute, then you can be informed about an action which is done under the hood. And how it exactly works. During the initial configuration of the setup, you need to define some specific tag, and this tag will be recognized by Lambda, and will start or stop instance. Of course, it depends on your settings. But when you create a schedule, the name you specify is used as the tag value that identifies the schedule. So you want to apply to the tagged resource. For example, during the installation of the Terraform module, the default tag name in this example is the schedule. So all the resources which are tagged as the schedule will be basically taken by Lambda, and then the specific action will be executed. And as you can see here, there is the value as the Australia office. So in this case, this schedule will be applied. All the information related to the instance scheduler are stored in DynamoDB. In DynamoDB, we have 3 tables. One table is the config table, where all the schedules are stored and the periods are stored, and also the configuration of the instance scheduler, about the maintenance window, and also the state table. All events which instance scheduler made all events are stored in this table. Okay, so let's go to the schedule and to what exactly it is. Schedule is something like piece of information which where you can define the name, periods, and time zone. The name is used by the Lambda, and also we need to remember that that schedule can basically are composed of one or more periods. So you can add one or more periods, and periods looks like that. You have we have, for example, office hour period, and in this specific part, we define when that period needs to be applied. So in our case, the office hours periods means that that specific instance will be run from the 9 a.m. till 5 p.m., but only during the weekdays, so from Monday to Friday. And it's really important to mention that you can define you can define the days in format like that. So we can define, for example, only the Saturday, and the abbreviation is SAT, etc. And also here we define the next period. The next period is the batch, and the begin time is 2 a.m. and end time is 4 a.m. So having those periods inside one schedule, it means that every resource which will be tagged as the Australia office will be run in office hours in batch. And it's really worth to mention that in every schedule you need to define the time zone, and the time zone is basically the time zone which define when those specific periods needs to be applied. So as you can see, we can have many schedules with different time zones, but which are using only those two periods. So if we have, for example, the instance which is used, for example, in Asia and in America, we can define two schedules, and they can be those resources can use those schedules as well. Yeah, so we have been discussing with many customers related to their preferences of disabling instances, and we saw that a lot of customers have the same problems and they have very similar working hours, for example. So we decided to prepare something like predefined schedules, which is something like installed schedules into the instance scheduler. And you can use those predefined schedules without adding your own schedules. So let's see on some examples. You can use the schedule from Monday to Friday or Saturday to Sunday, and you can use if the specific resource will be run in all day or only from the specific time. And here is the list of the supported time zones. But this list is really short, because each time zone and each schedule needs to be added as the separate record in DynamoDB table. So we used only the most popular time zones. However, if you want to create your own schedule, you can use more than 200 time zones. So if you want to use your own schedule, you can use the time zones from the list which AWS provides. And how to use those predefined schedules is pretty simple. you need to just add the tag to your resource in the following convention. So, for example, Monday to Friday, and you specify the time zone which you need to use from this slide. So, all of those time zones are supported, so you can use in this way. The next feature of the instance scheduler, as I mentioned at the beginning, is a CloudWatch logs. So this solution logs processing information for each tagged instance. You can see the results of the period rule evaluation. You can see the desired state of the instance during that period, and also the applied actions, and for example also the debugging messages, which are pretty useful during the troubleshooting. And those are three groups which you can find in your CloudWatch logs dashboard. You have log group related to the general scheduler messages, related to the event rules, and logs the output of configuration actions. So if you make any changes in your instance scheduler, all the information will be saved there. And also a very good feature is that instance scheduler can automatically add tags to all the instances. So when the new instance, when the instance, for example, is starting, it can add it add additional, for example, additional tag. And you can basically filter those resources which has been started or has been stopped. So you can take a look on those macros. Also, it's really useful information that you can use the macros in your tags. So the result of the scheduler tag will be something like that. If you use, for example, year, month, day, you will get information about in which day that instance has been started or has been stopped. As I said, the code is fully maintained by Amazonians guys, and you can basically write some specific feature if you want. You can contribute to this project. Maybe if you find some bugs or you have some specific idea, you can add to the GitHub. And also very useful board as the roadmap. You can take a look on that, and you can see all the features which, for example, they are going to implement that, or they are not going to implement. You can see that they have something like very clear roadmap on which they are working on a specific instance schedule feature, and it's pretty useful. Other features is something like the SSM maintenance window. It's really important because you don't need to worry that our instance won't be available during our patching process. So by default in the instance scheduler, there is an option that you need to specify that SSM maintenance window needs to be added, and based on that, the instance scheduler will know when the patching process will be executed, and it will start automatically the instance. And when the patching process will be completed, then the instance scheduler will turn off the instance. The next thing is that you can use the partial automation. So you can manually, for example, start the instance, and you can have automatic start, for example. The next thing is the RDS snapshot, which can be done before stopping. So as I said on the beginning, instance scheduler also can also be used by RDS instance. So sometimes we need to have something like guarantee that this instance has latest snapshot. So when instance scheduler wants to disable instance, it can also make a snapshot. Of course, if you wish to do so, you need to make the parameter, pass the parameter about the creating the snapshot before stopping. The next thing is the SNS integration. You can integrate many software with that, like Slack or Teams, and to be informed about the events which the instance scheduler is doing. Related to the instance schedule pricing, it's always very tough. The cost of the solution basically itself, because the instance scheduler is not a service, is the solution. So the solution itself is free. However, it uses some AWS services. AWS services under the hood, so you need to pay still for some of them. Basically, but in our experience, unless you have a very significantly resources, the costs are generally below the $10, something like that, or even less. But the price increase proportionally when you have a lot of instances. So, for example, in this case, you have we have a cost of the Lambda cost per month $1. But it's only for 2 instances. So if you have 4 instances, of course the cost won't be the $2. But the thing is that sometimes this Lambda needs to be executed longer. But it's not really it's not something like linear process. It's something like 10 or 20 cents per instance, something like that. But to be honest, I have not met the customer that doesn't save at least $10 on their resources when they implemented instance scheduler. The savings can be really huge, in my opinion. Okay, so let's go to the downsides of the instance scheduler. Instance scheduler does not support spot instances. It does not support EKS, ECS, and also now, of course, instance scheduler at the time being do not support the auto-scaling group. However, we will see, because there is a very big discussion in the GitHub about the auto-scaling group, and maybe they will implement it, because there is a lot of upvotes on the topic related to that. But in our organization, we figure out something like the custom resource from the Terraform, and you can use auto-scaling schedule, which is natively from the AWS, and the only one difference is that there is recurrence as the cron syntax, something like that, and you can define when the instances are scale out, when instances are scale in. As I mentioned on the beginning, natively AWS prepared CloudFormation module, but we needed to rewrite this module and to the Terraform, and we published this module on Terraform registry, and it's something like 2,000 downloads for now. all the time, and basically the code is open, and you can contribute also to this module. How to implement? Basically, you need to create Terraform file with implementation. Then you need to apply your changes. You need to remember about setting proper tags to your instances, and then our Lambda function will stop or start instance in the specific time. Yeah, as I said, the basic implementation is just 3 lines related to that. The more advanced is more lines, and here you can define your own schedule in this format. So first of all, we need to remember about creating periods. In periods, you define the time when the instance should be disabled. And you need to define also the weekdays, or you can define, for example, the weekend. So and that specific period you need to put inside the array in the schedules object under the periods object. Yeah, so inside this periods, you define how many periods should be applied in the specific schedule. And I also added the scheduler frequency, that it informs that the Lambda should be run once per minute. This instance scheduler can be used also in the multi-account solution. So instance scheduler is responsible for creation. When you deploy the instance scheduler on the remote account, the instance scheduler will deploy the cross-account AMI role, which you need to define inside the module, and it's also called like spoke account. So the spoke account is place where you have also some resources, EC2 or RDS. But basically, you don't have there the components from the instance scheduler. You have only one very simple AMI role, and yeah, and this is the implementation how it works on the remote scheduler. Here is the flag remote account deployment, where you set, and you need to pass also the scheduler account ID. Which identifies your master account, where all the components related to the instance scheduler are deployed. And this is the parameter which you need to pass when you have a multi-account environment. So inside the module, you pass the cross-account roles, something like remote roles, and those roles have been created while ago by the remote scheduler, and then you need to pass those roles. Of course, you can use something like maybe better syntax with the outputs or something like that. But but for testing purposes, you can hard code those roles inside the file. Here is the list of the links which you can use. So the QR code is going to the our Terraform module about the AWS scheduler, and there is also the roadmap of instance scheduler, which you can track all the activities from the AWS and in which direction they are going. Okay, and now it's about the live demo. I don't know if we have a time for demo. Okay. Okay, so this is our AWS console, and in our console we have one instance, and inside this instance, basically this instance is stopped, and we want to apply the scheduler on that. As you can see, there is no schedule tag, so we need to define some schedule. But for our demo purposes, I prepared already predefined. I already implemented the instance scheduler in this account. What we need to do is we need to apply the specific schedule on this instance. Let me change something because I need to switch to another monitor. Okay. Okay, now it's better for me because I don't need to see my workspace there. Okay, so I have prepared this module which is already implemented, and I would like to basically create some specific schedule and specific period. In our case, for example, we prepare the schedule which is called meetup time, and this schedule will be executed only in the Europe-Warsaw time zone, and it will apply the periods as the KRK PMI meetup time. And in our case, we need to define when the instance should start, and also we need to define the end time. So let's do it like that. That this instance should start in 7 p.m. 9 minutes, and also, for example, the end time of that. It will be something like that, so very, very short. And we need to also remember about tagging, about tagging of our EC2 instance. So as you can see, I added to the EC2 instance the schedule tag with the meetup time because it needs to be the same. And now I need to push my changes to our repository, and then I didn't commit. Okay, and now this is our Terraform enterprise workspace, and it has executed the trigger when the new commit appeared, and we will wait for the applying. So as you can see, there are some things which wants to be added to the DynamoDB, and also our EC2 tags should be added. So let's see. What about status? Plan finished, and now we need to run. Confirm and apply. Confirm plan. Apply is running. And let's see if so we have 9 p.m. 9 minutes, so I don't know if it will start at the correct time, but it should. Okay, let's see. It's still stopped in the tags. We should see the new tags has been added, meetup time, And let's go to the CloudWatch event. And inside the instance scheduler, we should see the information that this specific instance is scheduled to start. And if we refresh the page, it should be up. And
live demo. Woo!
Yes, and as I wrote inside the code, it should be end. It's in the next 2 minutes. So basically, we can wait, but believe me, it will stop. Okay. So what's more? Q&A. Do you have any questions, guys?
Okay, everyone, the questions are open. Do you have any questions, folks? All right, wait a second. I will bring microphone, okay? Because without microphone, our colleagues online will not hear us. So,
thanks. Can you explain briefly how this solution is better or different from using scheduled actions in auto-scaling groups?
It's better because auto-scaling group, you don't use auto-scaling groups in each cases. You can use, for example, the EC2 instance. You can have a EC2 instance in your environment, and based on the auto-scaling. Okay, but I think that maybe
Might be different. Yeah, you are using auto-scaling usually when you have production environments. When you have test environments, you would like to test it, but then probably you'll have some instances which will work independently in most cases, and you would like to stop it. So this solution is not addressing the auto-scaling, because actually we managed to address it, but the main purpose why didn't AWS recommend it for auto-scaling, because auto-scaling, as you said, have already built in solution which you can reuse, but only for auto-scaling. So if you have independent instances or RDSs which are not using auto-scaling groups and not working that way, the easiest way to stop it and stop the dev and QA environment is to use instance scheduler.
any other questions? All right.
I've got one. First of all, thanks for sharing this Terraform code, because we have a discussion with my friend that wondering that they will share this with us or not, but it's available. And the second question, how to convince the people to use the solution like you showed us, Piotr, at the beginning, especially on the development environment. We are facing exactly the same issue, and 1 month everything is fine. Next month everything is going down because the people are not properly using the tags and other stuff like that.
Yeah, I know the issue. Okay, so I would like to share one solution which we apply. We have right now in PMI, Willie Morris, 2 cloud environments. One is which we are calling AWS Classic, which is like fully managed by cloud operation team. However, it's still like the application team is taking care if the resources are up and running or not. And there, in this environment, we create for them a portal with graphic interface. They can easily click and execute the stop and start or apply the schedule. Yeah? In our more modern solution, means deep platform, which I mentioned many times in the previous meetups, we are sharing this Terraform code, and we are asking developers to reuse this and apply for the solution. However, it's like pretty difficult sometimes to convince them. Some of them would like to use it, some not. So we have the same idea for the future. It's not ready now, but we would like to integrate this solution with graphic interface, and also convince not developers but product owners, service managers to apply this and see the results of the cost optimization. Yeah? So this is our goal. This is our vision. It is in the roadmap. But yes, this is the most, I would say, difficult, challenging part is to convince developers to use it.
Yeah. Wait a second. I will just bring your microphone, okay?
I have also one thing to add. That
I thought that you would have a question. Oh, come on. All right.
I just wanted to add, because this question lays not only on the technical side. If your cloud operations are on the budget and product team, they don't care, then it's a real fight. If you implement a kind of recharging model so that each product pays for the product they host in the cloud, then the head of that product team will take care, because they will budget the money, and if they exceed the budget, they will care. So still cloud operation may have the total and formally pay, but then they recharge the cost of the respective products.
But for example, if you have a technical person and you have a development team, you can use something like policy checks, for example, in the Terraform, where you can require to use some specific tags, for example, and without the tag, instance cannot be created, for example, and based on that, you can the instances are scheduled, right?
I absolutely fully agree with you, and we started with some kind of config, but if you have 2,000 AWS accounts, each account have a different configuration and the different use cases related to the test. And I also fully agree with the budgeting, but sometimes at the organizational level, the development teams, they don't care about the budget because everything is over our master account and the consolidated billing.
Yeah, just make the bonus based on savings. It's gonna solve themselves. The problem will solve themselves. People are, let's say, run also by such a low priority like money.
Yes, but pushing from both sides. So having the mandatory task, and second way, I would say, have the recharge, which we also like applying in our organization. It will convince finally people to use the tool. Yeah. And this is the way.
This is the way. Any other question? All right, we have some comments online. Just add them, okay? Because Brian, who is a Boston AWS User Group leader, just make some points, right? So, Brian, thank you very much for joining us. Where is it? S3 intelligent tiering can be also a way to do it.
Maybe
right?
I will just comment. I didn't share all the best practices related to the cost optimization. There is a lot of solution which you can really deep dive related to the storage, or if you are designing totally brand new application, think about serverless. Yes, I'm focusing on this, what we managed to achieve and what brings us the biggest benefits, because currently we are focusing on the migration from on-premise to public cloud, to AWS, and we are migrating like 600 applications which you cannot rebuild, refactor from scratch and just replace the solution because it's constantly used by the organization. But yes, for this additional things like intelligence tiering, especially if you have like archiving solution, which we also would like to build in AWS, and you are transferring a lot of data, yes, let's use additional tools not related strictly to the compute. Here we focus on the compute because here we have like right now the biggest cost utilization.
Any question? All right, so my time. Okay, I have a question. I have two actually. So about the Cloud Watch, what is the position of the Cloud Watch in your, budget? It's a high when you're collecting the logs. It's consuming a lot of resources and money in the end, or you're not calculating that?
Yeah, about the usage of the Cloud Watch, it is of course used mainly in the production environments and in depth if you would like to benefit on execution and monitoring. However, the total, I would say, spending on CloudWatch isn't so high comparing to other services.
Okay. And the second one, because when we talk about scale, generally, whatever you do to optimize it have a huge impact on the bills, right? because you change a little bit something, and this couple percent it appears to be $100,000, right? When you have a small organization or smaller organization, don't you think that it will also bring, let's say, the percentage benefit, the same percentage benefit, or it will change because of the scale?
Okay, if you are thinking about like scale and your organization is growing, and then you can have a bigger benefits, but then you will also have more challenges if you will not apply it from the beginning. Yeah.
All right, that was my point to do. Apply it for very beginning, because this will enable your teams to just use to that and do it, organically.
And think about this during the design, during the architecture of the application and so on. So it's not only about building modern solution, but also taking care of the cost, like security. So you should have everything in the pipeline. Good design, security, and cost. Yes.
Yeah,
then the organization will be happy.
Go through this well-architected framework. I think it's a good way. And there is a pillar, the new pillar regarding carbon footprint, which sounds sometimes ridiculous on the very beginning. But when you think about it, the more resources you're eating, the more you're hurting the planet. So in the end, when you optimize that, you also do, you do a great job, right?
And actually, I think there is a feature is visible in the AWS console, in the billing dashboard, how big is your impact of the carbon footprint. So we need to think about this.
Oh, perfect. Thank you very much, guys. Hey, I'll give you applause for.
Thank you.
We'll do a small break, right? Okay, for a moment. There is a lady there. She's not sitting in a spotlight, but she has something which can be interested. So more vouchers. Okay, so she have vouchers. Kasia have vouchers. So enjoy, and remember, we have this quiz. And we'll pick the winner on the end, okay? So go for it. It's not something super hard.
And to convince you to stay, at the end of the second presentation, we'll also share some awards for the most active persons. So please stay with us. We have also one more slide, not related to cloud, to quiz, but to the community day, which is coming, and we have been asked to share with you.
Yeah, guys.
Also.
So we're doing a great gig, right? So in Warsaw, in 14th of October, I think, yeah. So 14th of October, it's going to be a great gig. It's community day. So all the communities from Poland organizing after pop-up hub in Warsaw AWS event. We staying one day more, right? And we're doing a community event. So some presentations from the people, present to the people what we do, what they do, how they face challenges on the with the AWS, how they use the technology. Hopefully you will join us, of course. And you're all welcome. The event is free, right? So you need to just travel, have fun, and stay next day. But not, you don't need to, but well, I think we'll organize something afterwards. It will organize itself probably, community love party in the end, right? So enjoy your break right now. We will have another session about IoT, which is super interesting because this is something which you can use not only in a company, but you can use it for yourself, for your hobby, or for stuff like this. So yeah, wait for it. Thank you very much.
You've got the water. It's finishing. You have 2 times. Dirty glasses. Wherever you.
I am saying, just here for the night. Okay. Yrno? Like,
here, so don't worry. Nothing will run from you. You ready? Sure. Oh, perfect. Great. Okay. The beers always have this gravity, you know. Yeah, very good. Okay, everybody. So Yrno, today we'll talk about AWS IoT Core, and I think that yeah, let's start like this. We start right now, and Yrno, the stage is yours. The microphone.
Perfect. Thank you so much. Welcome, everybody. My name is 𝓗𝓮𝓿𝓻𝓮, and today I'll be giving a high-level introduction to some of the core functionalities of AWS IoT Core. My name is 𝓗𝓗𝓿𝓻𝓮. I am a cloud application architect with AWS Professional Services. I've been working with AWS since September 2020. And at Professional Services, we help companies migrate to the cloud and build cloud-native solutions. In my office specifically, we are very much focused on cloud-native solutions, re-architecting existing applications and such. Our office is located in Warsaw. This is also where I live. Not my entire team is located in Warsaw. We're all over the place, but that's where we have our office. Outside of work, I love to do snowboarding, wakeboarding, and some climbing, and some traveling, of course, too. And on my day-to-day basis, I work with a lot of AWS tools, naturally, you should expect, but also with AWS CDK, Cloud Development Kit, for provisioning this infrastructure, sometimes Terraform as well, and Python, TypeScript, and some front-end frameworks such as React and Vue.js. But today I will be talking about IoT Core. IoT Core is a service that allows you to securely connect devices to the cloud and others without having to provision and manage servers. This is what we call a serverless or managed service that allows you to securely connect your devices, route, process their data that they are sending or receiving, and have them interact with each other, even while they are offline or in completely different locations. And on top of that, you're able to integrate with a wide variety of AWS services to, for example, be able to do analytics on your data or monitoring, logging, as you'd expect. So let's go to the basics real quick and talk about things. Who here has a smart device at home? Any device that's semi-autonomous, connected to the internet? Okay, quite a few people. Have any of you ever experimented with creating IoT functionalities with IoT Core, for example? I see one hand. Great. All right, so a thing, it's essentially a smart device, a device that's connected to other devices or the internet. Usually it has some interactive component and some level of autonomous functioning as well. And quite common as well are sensors that are transmitting telemetry data. And a thing is also the way we refer to the physical device within IoT Core. So it's the digital representation of said device. Now, things, as you can understand, they come in a wide variety of, they're in a wide variety. There's lots of different kinds of things. And doorbell, a sensor, like I mentioned before, these can have different properties to them. Imagine, for example, a version or whether or not some kind of hardware module is installed, and such properties. So in order to manage these properties, IoT Core has a device management module where you're essentially creating or onboarding your thing, your device, and assigning it some properties or attributes, and based on that, do further management with your device. So to simplify managing your things, as you imagine, at some point, you're going to have to scale up and manage a lot of devices at the same time. There are a few mechanisms that IoT Core offers you to simplify this. The first being thing types. So imagine you are a company that's making smart devices and you have different product lines of different kinds of products. And a thing type essentially is one kind of thing that has a lot of properties in common with other things. So these are, device-specific properties. If we're talking about the doorbell, Ring might make multiple versions of a doorbell, but in essence, they are the same thing. They are a doorbell, and they have certain properties that they all share, which is where you would use a thing type. So a thing type is a logical grouping. And the reason that this is useful is because we can assign attributes to a thing type, which we then also assign to our thing by extension. A thing has one type, and it allows you to, more easily manage your things without having to individually go through all these things and add these searchable attributes. Now, you might be thinking, what are searchable attributes? Why would we need them to begin with? Searchable attributes are these characteristics of the device that you will be using for a number of features, such as, for example, being able to update all the devices that match a certain characteristic at the same time without having to individually approach all these separate devices. So once you start using a thing type, you are able to add 50 searchable attributes to a thing. I realize now that there's a small typo in my slides. The first line is supposed to be without the thing type, so you have only 3 searchable attributes for a thing without a thing type, and once you add a thing type, you suddenly have 50 available. And you're able to create unlimited thing types, so go nuts. Make as many as you want, but only one per thing. Now, the next logical grouping, which sounds kind of similar if you're hearing them in succession, is thing groups. And thing groups, they are used for slightly different purpose. So thing types, imagine them as some defaults that you have for your device. Whenever you're onboarding a new device, it's not starting from scratch, but you assign it the thing type and it automatically inherits all these properties. Now, a thing group is more for after you already have your device and you actually want to start doing things with it. For example, like I mentioned before, upgrading the software on this device in a batch for the entire group in one go. And there are 2 ways that you can make groups. First being a static group. So you create a group and you are you yourself are responsible for adding or removing devices from this group. Of course, you can do this in an automated fashion, but there are actions you need to take to actually add or remove a device from the group. You're able to nest groups, so you can put a group in a group, and that allows you to do some nice things. For example, you can attach policies to a group. Policies are deciding what your thing is allowed to do within IoT Core. We'll talk about it a little bit more in a second. If you nest these, then you can very easily manage your ever-growing fleet of things. Next up, we have dynamic groups, which you are not able to specify yourself. You're not adding things to the group yourself, and instead you are specifying a query. This query is looking at these searchable attributes that we were talking about just now in thing types. So you can specify a query that's looking for certain values at certain searchable attributes, and then groups them together within a thing group. You can only have up to 100 thing groups per account, so that's something to consider. And additionally, they cannot be nested, and you cannot put policies on them. Instead, you would, for example, use them rather to perform jobs, such as updating the firmware and such. Whenever you are performing an action on a group, it's automatically cascaded to any subgroups or the things within the groups or child groups. Last thing I wanted to talk about when it comes to device management is the certificate and the policy. So a thing will have a certificate which we use to authenticate the device or the connection. The policy is then attached to the certificate. There can be multiple policies attached at the same time, but the policy is stating what actions the thing can actually do within IoT Core. So to make this a little bit less abstract, I would like to show you by onboarding a device. For this, we are going to head over to the console. Right, here. Okay, so we're at the home of the AWS console. Quick question, is there anybody that's not familiar with this screen? I'm just curious, I don't know. No hands, that's a good sign. So I'm just gonna head over to IoT Core. Right here, we're on the homepage of IoT Core, in case you're not familiar with it. And on the left is our sidebar, where we will head over to device management. As you see here, manage. We get on this page. We can also go to the devices page, but it's okay. We'll click here on the create a thing button and we'll start creating our thing. We have to give our thing a name. This is a simple unique identifier. For the sake of this demonstration, I will just go with sensor 1. And then we have additional configurations. And here are some of these topics that I talked about before are coming back. We have the thing type, which we're able to select, and we have thing group. We can choose to assign our thing automatically to some of these static groups. Keep in mind, static groups are the groups that we manually have to, or at least we have to take an action to add a device to the group, and dynamic are the ones that we don't have so much control over. So I've created on create a new thing type. There were none configured yet, so I will go ahead and create a new one for the sensor. And we can here configure our searchable attributes. So this will allow us to make these dynamic groups through the queries that are actually looking at these searchable attributes. So we're able to add some some values here that will then be applied to all the things within said type. For the sake of this demo, there's also the device shadow at the bottom. We will talk about this later. For the time being, I will keep it on no shadow. But in a moment, I'll discuss a little bit more in depth what this is, because it's also really nice functionality. So on the next page, we have our certificate configuration. We're able to provide our own certificate. We are able to provide our own certificate authority and use that to make a certificate. We're also just able to take an auto-generated one that AWS gives us, which is what I'll go for this time around. And then next up is the policy. Like I mentioned, we have the certificate. To the certificate, we have to attach the policy. Certificate we use to identify the device, and the policy then actually dictates what the device is allowed to do. I will go ahead and create a new policy, which we can do with the click of a few buttons. We once again have to name our policy, and then we can actually start building it. There are a few different ways you can do this, but I recommend that you start from the examples. There are a few very straightforward use cases, for example, connecting your device to IoT Core, publishing and subscribing to some messaging topics. I'm going to go ahead and select these two and click add to policy to actually add them to my policy. See, it's moved us back to the previous page just now where we have the policy editor, and we can go ahead and further customize these policies if we want. But just to break it down real quick, there's a permission being added. So we're saying, okay, we want to allow to connect to, for any resource that's a client with client number 1 as its name. And if we look at the last one, for example, we are allowing the device or whatever entity our certificate is associated with to publish to a topic that's starting. In this case, they're using some dynamic value here, which is the thing name. This will allow you to really easily separate messages from one device to the other. So in the policy, we can ensure that our devices will never be reading messages from other devices. since it's baked in with the thing name right here. All right, once we are satisfied with our policy, we can go ahead and click create. So now the policy has been created. We can go back to our thing onboarding, and we see right here that the new policy, it was 1P. It has been added to the list, and we can now select it and move on. So now the thing has been created within IoT Core, and as we asked AWS to generate for us the certificate and the credentials, it has done so, and it's providing it to us here. So you can go ahead and download those files to actually get them on the device so that the device can actually authenticate itself. All right, it's wanting me to download it, but we're not going to do that. I already did that. Let me go ahead and hop back to the presentation. Because now that we have onboarded our device, now that IoT Core is aware of our device and how our device will try to authenticate itself when connecting, we have to talk about how we're actually going to be communicating with the device and from the device to the cloud, of course. For this, we'll be using MQTT, which is a message queuing telemetry transport protocol. It's a very widely adopted, lightweight protocol for constrained devices. And it essentially comes in 3 flavors, of which IoT Core supports the first 2. So quality of service level 0, which is at most once delivery of the message. So this means IoT Core or your device is sending out the message once, but it's not actually validating whether or not the other end has received the message. It's just sending and forgetting. Quality of service 0. Quality of service 1 is at least once delivery. So we'll send out the message, we'll make sure it's arriving. If it's not arriving, we'll send it again. But this might also mean that the message will arrive multiple times. If you are leveraging quality of service 1, you're going to have to think about how to deduplicate your messages. It might happen that a certain message gets through twice because the sender does think the receiver has not received it yet, and the moment it resends the new message, it suddenly arrives. So on the receiving end, you're going to have to take this into consideration as a possibility. Now, quality of service 2 is exactly once delivery. So here, the protocol is taking care of the deduplication. However, this is unfortunately not supported by AWS IoT Core at this time. Now, how does MQTT work? Essentially, the clients are subscribing and publishing messages to topics. And you can subscribe to multiple topics at the same time. And you can create your own topics at will within IoT Core. Now, there are also a number of reserved topics. These are the ones at the top. They are reserved for some functionalities of IoT Core. This can have to do, for example, with device onboarding. But later on in the moment, we'll also look at some other ones that have to do with this device shadow that I've mentioned before. Keep in mind, topics are case sensitive. And you're also able to leverage wildcards. Wildcards make it really easy to subscribe to multiple topics at the same time. And a wildcard is essentially just a way of subscribing to an ambiguous topic or subscribing to multiple topics at the same time, like I said. So the first wildcard, the hashtag, it matches anything that is matching the first part of the pattern, and anything that comes after that, they will all be matched. As you can see here, if we have sensor hashtag, then sensor and temperature, sensor temperature room 1, any message sent to those topics would match. The next one is for when you want to have a substring in the middle of your pattern that you want to be able to freely match. And in this case, both the temperature and the humidity sensors from room 1 would be sending their messages, and we would be receiving them if we are subscribed to this wildcard topic. One thing to note is that you can only subscribe to wildcard topics. You cannot publish to wildcard topics because you need to publish to a specific topic. You cannot publish to an unspecified. Yeah. All right. Now, before we hop into the demo, I will show you a really small code snippet. this is JavaScript. There's the IoT SDK for JavaScript, which allows you to very easily make connections and send and receive messages using MQTT and IoT Core. This SDK is available in Python, Java, C#, and JavaScript. And yeah, this is how simple it really can be. After you've, of course, established your connection with your certificate and such, then you can just publish a message. The first parameter would be the topic that you want to publish to. The second parameter is the message body or the payload of your message. And then the third parameter is the quality of service of MQTT that you want for this publish. As you can see, we have at least one, so quality of service 1. Now, we can publish, but we can also subscribe, of course, to receive the messages. Looks very similar. The first parameter is once again the topic. In this case, I've included the wildcard. The second parameter is quality of service, and the third one is a callback function, which will actually process the message once it is received. Now let's look at that in action real quick. And for this, I shall sorry, I'm messing around with the screens. Which one is mirror? That's mirror, right? There we go. Cool. Okay. So here we are. On the right-hand side, we have my implementation of a client using the JavaScript IoT SDK. And on the left-hand side, we once again have the IoT console. I'm just on the homepage of the IoT console because I want to show you a nice little functionality that's here. On the left-hand side in the navigation bar, there's a test section, and they have an MQTT test client, which allows you to subscribe and publish to topics, which makes it very easy to test little prototypes like the one that I have made over here. So let's have a quick look at the implementation. We start off with creating a connection. This is probably at first the thing you're gonna have to think about a little bit. We are using the SDK to simply to configure our connection, our client ID, our endpoint, and our certificates as well, in order to be able to authenticate our connection. I will not go into it too deep at this moment, but once we have connected, as we are doing right here on line 19, we will then subscribe to this same wildcard topic that I've shown you in the slides. And after we've subscribed, we will publish 10 messages on this topic right here. Now, for the sake of this demo, I will also subscribe to this same topic in the IoT Core, in the test client. If it lets me. For some reason, the button was not appreciative of this. But okay, here we are. We're subscribed. So yeah, you'll see the messages pouring in once they come in. You can subscribe to multiple topics at the same time. This goes for both your local clients, but also for the test clients. I'll show you that we have now both here. And as they come in, we will see them both light up. So let's go ahead and run this. So as I said before, first we are subscribing to the wildcard. And keep in mind, this wildcard, it also includes our topic that we are about to publish to as well. So first we're subscribing, and then we're going to receive our own messages. And then we'll also send a message from the client right after that. So if I go ahead and run this script, you see it went pretty fast, but there's a little bit of a delay, but it connected, then it subscribed, and then it started publishing. And you see here on the left and on the right sides that the messages were received by both. But as you can see, they are not always unique, since we're using quality service 1 and there's no deduplication. So it can happen at times that a message arrives twice. But right here we see that our wildcard topic has also picked up on this on these messages. Now, if we go ahead and publish from the MQTT client, we can publish to anything. We were publishing to temperature, but let's say we are publishing to humidity right now, and we're going ahead and publishing this. Then, of course, in the specific subscription where we are specifically subscribing to the temperature topic, we're not receiving this new message, but right here in the wildcard topic, you see the humidity message has come in, and the same thing goes for our client because we're also listening to the wildcard topic. All right, now I have a few more last slides. If I can. All right, there we go. Cool. Now, why is it so dark? That's better. Device shadows. As I mentioned before, device shadows I think is also a very neat functionality of AWS IoT Core. Essentially, what the device shadow is a persistent state store for your device in the cloud. And it can store data from your device itself or from applications that are running on the device. It's very useful for persisting data past reboot or, for example, manipulating the state of your device from, for example, a web application where you're remotely managing your devices. There are two different kinds of shadows that you can have. Unnamed, which you can only have one per device, and named, which you can have multiple per device. For the rest of this presentation, we'll be looking at unnamed shadows, since it's a little bit more straightforward, but in principle, they are essentially the same. The only thing that differs is the topics you will be using. So in order to interact with the shadow of a device, you are going to have to subscribe and publish to MQTT topics. It works the exact same way as when communicating with our custom topics, but we're going to be leveraging some reserved topics right here. The first ones that you're going to have to subscribe to have to do with updating the shadow. So whenever you're trying to update the shadow, you will do so by sending an MQTT message. And once the update has either been processed or it hasn't happened, then you will get a response on the topics that are meant for this. So in this case, we have update accepted and update rejected, the top two ones. If the update goes through nicely, then they will send them AWS IoT Core will send a message to update accepted. And if for some reason it fails, then instead there will be a message on rejected. So you can imagine you can build very nice event-driven logic based on this as well, both on your device, but also outside of it. Then the next topic is delta, which will allow you to check the difference between the state of your device and the state that we have in the cloud. It can happen that they sometimes are not 100% aligned if the update, for example, has not happened yet, or the device for some reason thinks there has been an update, but there hasn't. Actually, in order to be able to manipulate the state or the shadow, we have some topics that we can publish to. The first one is about getting the shadow. We'll publish a message here if we want to retrieve the shadow. And the second one is about updating the shadow. We'll send there the actual contents of the state that we'd like to update. Now, what does this look like when we publish to the get topic? This is what we will get back. So there's a state, and the state has a reported state, which is essentially AWS IoT Core's consensus on what the state is. So this is what the cloud state says is the state. And you can define your properties here. So for example, we can turn on and off an engine on a device. And when we're updating it, it looks very similar, but instead of reported, we have the desired state. We're trying to tell IoT Core that we want the reported states to be updated to be matching the desired states. In this case, engine is on. And like I mentioned, when we send this this message, we will get a response on whether or not it was successful, either on the accepted or rejected topics. So far, device shadows. Now I want to quickly mention a big customer that has been using AWS IoT Core for some time now. It's iRobot. They make autonomous vacuums. I'm sure you are familiar with the concept. And at some point, they were going to release a new vacuum that was connected to the cloud. And all of a sudden, they had to manage a lot more traffic than they were used to being a hardware vendor originally. But luckily, with AWS IoT Core, which has a high throughput, which can handle a high throughput of messages and lots of devices connected at the same time, they were able to scale and keep the cost of the cloud platform low by adopting serverless architecture, leveraging IoT Core. Now, if you are interested in giving it a shot yourself, if you want to play around, I think it's a really, really fun set of services. There's really fun things that you can make with it. To get you started, I recommend checking out these links. The first one is just the developer guides, the documentation. If you're using AWS services, I'm sure you're familiar with it. But this one is actually really nice because it references a lot of other resources that are really useful in getting you started with your IoT cloud journey. And secondly, we have workshops.aws, where there's also a number of IoT workshops available. And with that, we have reached the end. I want to thank you all so much for your attention and for having me here. Add me on LinkedIn if you have any questions. If you want to talk about anything, I'm always open, or walk up to me. All good. Lastly, I want to put out there that we as professional services from the Warsaw office are hiring. Now I'm saying Warsaw office, but you don't have to be in Warsaw. You can be anywhere in Poland. We have virtual contracts. We have here Grzesiek as well, who's our coworker from Kraków, but we have Poznan, we have Wrocław, all over the place. Here are a few links. This is not everything. There's a lot more. These are just a few that I've picked out. So if you're interested, snap a picture or something. And otherwise, come and talk to me. And that's it.
Yeah.
Thanks again.
Perfect. Thank you very much. Any questions? Okay, I will just take this microphone and give it that. Okay.
All right.
Okay.
So I have a question. I saw you are like working with like big brands, iRobot and so on, and it is working perfectly when you are using usually one brand. Yeah, but are there like solution which you can build by yourself to connect multiple different brand the devices and reuse the same technology to manage them all? Yeah.
So in my projects, I've simulated a high amount of devices just by spinning up lots of Docker instances in one go. Just running your same, you can run the same script with some different parameterization and yeah, you can onboard them all in one go and manage them with these policies, different topics, thing names, of course, are uniquely identifying them. So yeah, there's definitely lots of ways that you're able to do this. Yeah, for sure. And Docker, that's for me, that was one of the most convenient ways to be able to iterate pretty quickly.
Any other question? All right, wait a second. I'll just go to you.
So you described how device and showed us how it will exchange messages with SQS, but as far as I can see, this means that if someone will decide to use that service, there should be some infrastructure or solution around managing authentication. So each device have to present valid certificate in order to be able to talk to service. Is it right?
Yes, totally.
And this means there should be a solution of managing certificates on each particular device. How does
Definitely.
that look like? And is there any other service, a part of that service around which will simplify that certificate management?
Certificate management, honestly, is a very, very, very tough topic. This is also why I did not spend too much time on it during the session, because it's very, very complicated, and there are a lot of different ways you can achieve this. One way, for example, to onboard your devices, I'm not saying that you should go ahead and do this, because there's concerns about this as well. But for example, if you're producing your device in the factory, you can embed it with a bootstrapping device, which you will then be able to use to make a first-time connection to IoT Core, and there you exchange the bootstrapping device for a device-specific certificate, which then has the device-specific policies for the device-specific topics and everything connected to it. There's a lot of different approaches, a lot of different ways, and IoT Core, I think they handle it in a pretty nice way. They're offering you really the possibility to pick the solution that works best for you, and you really have a lot of flexibility there. So it's hard for me to give a one clear answer on how to do this. I think I'd be rich if I had it, but yeah, you have a lot of possibilities. And like I said, this onboarding certification, yeah, there are possibilities to do this in a scalable manner that will not have you go around and create manually generate these certificates for each device, downloading them, putting them on the certificate, and such. Like I showed as well, or like you could have seen during the presentation, when I was creating the device, there was the option to specify that we want to use our own certificate authority. So that means we have our own certificate authority, which is signing all these certificates for all our devices. We put them on there without them having to come from AWS in any way. You have the devices on, you have the certificates on your device, and then they are able to also onboard into IoT Core.
Okay,
I hope that's kind of somewhat answers your question. It's a complicated topic, like I said before. We can definitely further discuss for a really long time.
All right. Any other
And
question?
of course.
All right, please.
Hey, like you said about this MQTT service with QoS1, okay, at least once delivery. Do we have a timeout for that? Because in case of a stable and unstable connection, I think this works differently. That's what my understanding is.
Yeah, that's a good question. There's definitely some timeouts. I don't know exactly the number. Apologies for that.
Okay, because like in case of SQS, if it is using the backend or the backbone for SQS for this particular service, in that case there is a timeout for the messages, right? But in this case,
you're talking about the visibility timeout on
yeah,
SQS messages.
Yeah. Because
so
to
I
ensure
cannot confidently say that they are using SQS in any way. So I would not assume that those are in any way related.
I was just curious how you maintain QoS1
Right.
at least once delivery in case of an unstable connection.
Yeah, about the timeout, that's a good question. We can maybe discuss about this later.
Sure.
I can get back to you on this
No
because I don't know the specifics about that particular factoid.
Okay, any other question? Can I have a question? All right, perfect. Yeah, cool.
Of course, why
All right,
not?
perfect.
have the
There is
microphone, so.
there is a thing that it's sometimes good to digest data at the edge. Do you have any solution for that? Because I am sure that you are.
Definitely.
So you just don't send everything like to cloud and then process it, but do it on the edge and process what you want, right?
There are a number of solutions for this. You can, for example, run Lambdas at the edge, but we also have what we call the green grass device, which is, especially if you're into industrial IoT, it's a really a big thing. It's essentially a middleman that you have on sites or at least close to your devices. And the devices are not directly connected to IoT Core. Instead, they are connected to the Greengrass device. On the Greengrass device, you can do lots of processing or also run other applications. One time I was doing an industrial IoT project where we were developing a messaging broker that we were running on the same device as the Greengrass, or at least close to where the Greengrass was, so that we could achieve quality of service 2, at least within the factory. So yeah, there's a lot of possibilities here. It really depends a little bit on what exactly you're trying to achieve, but this Greengrass device, it offers a lot of possibilities, as well as reducing latency and the volatility of the connection between your device and an IoT core.
All right, thank you very much. Any question, Pawap? All right, thank you. A little bit of applause for our guest here. Woo, thanks
so
very
much.
much. Okay, so gents, yeah, just chit-chatting around. You know, you don't waste your time, man. Okay, we had this questions quiz like we presenting right now. So should we do it right now, or should we give to the most active people? All right, the most active people. It's your job, man. I will just handle that.
Yeah, so first I would like to start with the most active people during the, I would say, on-site audience. Then we can share the quiz online winners. So we have like stuff here prepared for you. I think it will be nice and quite interesting. For those who are online, you can win vouchers for AWS, like if I'm correct, $50 to utilize on your resources. So let's start. Yes. Yes, it is in Polish, but u nas zostaniesz seniorem przed 30. So in PMI you'll become senior before 30.
Guys, the first person.
Yeah, I can see the one of the winners.
Somebody, look at me on stage. I wish you to say something next time, you know.
Yeah, so thank you for the questions, and yeah, congrats. I have two more. Yeah, I saw that someone there was asking, but I don't remember who, about autoscaling. Yeah. Yeah. So congratulations, and yeah, already a senior. Yeah. And one more person on the second part of the presentation today. Yeah, so I think here is our winner, last winner. Congrats. Thank you very much for your questions, and congrats.
All right. Okay, the pleasant part done. If you have more vouchers, you always can stay here. No worries, we will not kick you out. Maria, do we have winners for the part of online? Yes. Should I read them, or should we take them home? Okay, I will read them. Okay. So we have, oh my God, I need to read the first part of the emails, and there are guys who just, like play with that stuff, right? So there is a douchebag 15, I just kidding. So it's a dash, oh my God. Let's start from the back, okay? So 𝓗𝓮𝓿𝓻𝓮. This is going to be the person online, so don't worry. Or here, there is somebody
Congrats
here.
to him.
Her, I think so. And you. All right, perfect. You will get the email. Don't worry. You will undertake it, huh? Woo. No worries. And Dasha Heb 15. If you're 15 years old, you are not allowed to get it, but I hope not. Yeah. So thank you very much for participating. And guys, we're closing the 60 meeting of AWS User Group Kraków. My name is Maciej Lelusz, and I want to thank you very much. And what is most important, be part of the next event. It's going to be in a month, around about a month. We'll meet. Which date? 26 October. Yeah. So we will meet probably here or somewhere else. We will see. Never mind. But the most important, be part of it. Join us. And if you have an interesting subject to talk about, just find me on Twitter. And yeah, we will put you on stage. Thank you. Dziękuję.
You too.